1, absolute value with an equal sign. And someone at the end of class asked me about the number lines. Do we not have to put a number line? When do we have to draw our solution on a number line? When it's an inequality only. When we're doing absolute value with an equal sign, how many answers do we have? Usually 2, but not always. Now there's quadratics in here. How many can we have with a quadratic? No, up to 4 possible solutions, because we've got a quadratic, and for each one we could have 2. For example, if we did, so let's write type 1. Okay, let's try this. So what do we do? So it's an absolute value with an equal sign, so there's 2 cases. Either the inside of this bracket is equal to 2, and that would work because the absolute value of 2 is 2, or the inside is equal to -2. And we have to solve each of these, and so there's 2 possible answers maybe here, up to 2, if it works. And the same here. So we could have 4 answers if both of these work. We saw last class all the different situations. Maybe one of them has no solution, the other one works, and they could both have no solution potentially, and there'd be no answer that works. Always move it all to one side and then say, does this factor? 2 numbers to multiply to give 2. 2 and 1. And subtract to give 3. So 2 and 1 are the only ones that multiply to give 2. Can we subtract them to give 3? No. So what do we do if it doesn't factor? Quadratic. Minus b plus or minus square root of b squared minus 4 times a times c all over 2a. Square root of 17, does that work out nice? No. If it had, that would have meant, oh, it was supposed to have factored and I just missed it, but you could still use these as your answers. So there's 2 answers. Minus 3 plus root 17 over 2 and minus 3 minus root 17 over, and you just leave it like that. You could write them separate, one with the plus and one with the minus and commas, or you can just leave it. So there's 2 answers. What about this side? Does this one factor? Yes. The 2 and 1 multiply to give 2, and they do add to give 3. Setting them both equal to 0, we get 2 more answers. So our solutions are minus 3 plus root 17 over 2, minus 3 minus root 17 over 2, minus 2, and minus 1. 4 answers. But again, if you look back at notes last class, we saw when they don't work. How could this not work? Maybe this gets a negative under the radical when you try to use quadratic equation, which would be no solution. When else do we have no solution? When it's a sum of squares. Sum of squares has no solution. So those 2 situations, we'd have no solution. Either you use a quadratic and you get a negative under the radical, or it's a sum of squares. We saw that last class. Okay, so type 1 we've done. We did that last class and one more example today. Type 2. So type 2 is inequality with no absolute value. So there's not two cases, because we're not finding when the absolute value works for negative and positive. There's not two cases. It's an inequality question we just solve. Now, we've done this inequalities like 2x plus 3 is less than 4. Okay, this is an inequality question. It has no absolute value. The highest power here is x. That's linear, which means we can just rearrange it. So this is what we had done before. We would just rearrange this. So 2x and this would be the type you would put on a number line if we were asked, because you can show that it's more than one solution. So on a number line, we have a half. We would put an empty circle, meaning we don't want the half to be included because there's no equal sign, and we shade. Okay, so that's what we had done before. What's the only difference between an inequality, where we rearrange and solve, and a linear equation where there's an equal sign and we rearrange and solve? There's one difference. Yeah, you always want to move the x's in these ones to be positive, because if you have to divide both sides, when we divided both sides by 2, that's okay. With an inequality, if you divide both sides by negative, it actually switches the sign, and that's kind of complicated. You'll have the wrong answers. So, for example, a second example, let's say we have 3x plus 1 is less than, let's put it equals, less than or equal to 5x minus 3. Okay, so the difference is we don't just rearrange it, we rearrange it so the x's are positive. So we have to move the x's to the right in this case, because we've got more x's on the right, 5x. So when we rearrange this, we're going to bring the 3x to the other side. So 5x minus 3x, that automatically switches the sign for you so that the sign is flipped. So 2, and then we switch this around carefully. This is x, it's pointing to the 2, so less than 2. So the bigger part is to the x. Equal, so color that in, and greater than 2. And if you're confused by this, how do you check your answer? Not the 2, no. How do you check your answer? The 2 will make them equal, but that's not showing you that it's the right side you plugged in. Right, check a number bigger. Say plug 3 in and see if it works. So let's do that. If we plugged 3 in, so say we're going to check. So our original equation, before you switch it around, that's what you use for checking, say we wanted to put a 3 in there. So what happens? We get 3 times 3 plus 1, 5 times 3 minus 3. So 3 times 3, 9 plus 1, 10. 5 times 3, 15. 15 minus 3, 12. So you look at this and you say, is that true or not true? True or false? True or yes or no, whatever you want. Check mark or X. Okay, so yes, this is true. That means that side is the right side. It works in the equation. What if we try a number less than 2? What will happen? So 3 plus 1, 4, 5 minus 3, 2. Is 4 less than 2? No. So that's saying that this side of the 2 doesn't work. Okay. Now that checking is how we actually solve quadratics to figure out which side to do. So let's write a quadratic one instead of linear. So quadratic inequalities. Okay, so I just have greater than or equal to 0 to start, just to make it easy. A positive number will work, and if we end up with something that makes it negative, then it won't work. Equals 0, so 0 is okay. So when you see a quadratic and an inequality, remember there's no absolute value in these ones. You don't write more than one case, you just solve this one. But the method to solve is a little different. We can't just rearrange, and we actually don't just factor either. What we do, step 1, is to change the sign to an equal sign. Step 2 is to factor or use a quadratic equation. To find the roots, which are the solutions. And 3, put the roots on a number line. And test a number in each interval. Always back into the original. And then you're going to write your solution, okay, with your greater than or less than signs. Okay, so I'll wait for you to write that down, then we'll do an example. Okay, so x squared minus 2x plus 1 is greater than or equal to 0. Step 1. Change the sign to an equal sign. So you rewrite it with an equal sign. And then you solve the quadratic by either factoring or using a quadratic equation or whatever works. So does this one factor? What two numbers multiply to give 1? Only 1 and 1? Can we add them to give a 2? Yes. If they're both negative, it'll give us a negative 2. And that's called what? Perfect square. There's only one solution. X is 1, because this gives us a 1 and that gives us a 1. So, step 1, change the sign to an equal sign, solve, find the roots. There's only one root. So what do we now do with the root? Put it on a number line, and we're going to test either side of that. So what are the intervals? This is the interval x is less than 1, and this is the interval x is greater than 1. There's just two places to check. So what would be a number less than 1? 0, negative 1. 0 is nice to plug in. What about a number larger than 1? 2, 10, 100, doesn't matter, okay? Whatever number you like. I personally usually choose like 10. It's easy to do, but 2 works nice. Okay, where do we check these? We're trying to find not where this is equal to 0, which is at 1. That's equal to 0 at 1. We changed it to an equal sign. So that means if we plug 1 in to this, we get 0 as the answer. We want to know where it's positive. What numbers can we plug in? Is it on this? If this is 0, think about temperatures. If your temperature is 0, on one side is positive numbers, and then on the other side is negative, right? So what we found was the 0. Where it's 0, we want to know which side of this will give us positive and which one will give us negative. A 0 is always like a switching point. Okay? We're going to switch on either side. When we do graphing, I even call it the switching point. Okay? Where we switch from one to the other. So we're going to plug these in, always into the original before you did anything to it. So write down your original equation. We're going to plug x is 0 in first. So 0 squared minus 2 times 0 plus 1. And that is either going to be positive, true, or negative. 0, 0 plus 1. Just 1. Is that true? Yes. So this side worked. What about the other side? If we plug a 2 in, 2 squared minus 2 times 2 plus 1. What do we get? 1. Is 1 bigger than 0? Yes. Okay. So I said that was a switching point. One side's negative and one side's positive. So how come we actually got positive on both sides? Do you remember doing parabolas in grade 11? Like you did them for a few months. We're going to draw them in the next chapter, but let me remind you. If there's one root, here's a graph. Okay, if there's one root at 1, here's what our parabola looks like. And what we did is what? When we were testing a number in this parabola, what did we do? We plugged a 0 in, and we got it as a positive answer. Do you see that that goes up? It's y value is positive. And what about this side? We got a 1 on that side as well. And that's like the y value. So when there's one root, what happens is the parabola either opens up and it's both positive, or could it be both negative on either side of? Sure. How could it be both negative? If there was one root, one place where it crosses the x-axis, and it opens down, then they'll both be negative on either side. Okay, so we'll go back to this. This is in Chapter 2 that we're going to look at that more closely. But back to here. So you can get both. So why I want to show you this is because you always have to check each interval. Okay? So sometimes they'll switch, plus and then minus, or minus and then plus, and sometimes they'll both be the same. You have to watch out for that. Okay? Most of the time they switch. But you can't just say all the time they switch. So what's our answer to this question? So they both work. And we want it to work. Both sides work. Do we want the 1 included? Is there an equal sign here? Yes, so we want the 1 included. We want it to be equal to 0. So what's the solution when both sides work and the 1? X is an element of real numbers. So the solution for this one is that x is an element of real numbers. What if I wrote that same question but didn't put the equal sign? How does that change? So we got 1 when we changed it to an equal sign, and this side works and this side works, but do we want the 1? No. So the solution, if we were to graph it, would actually look like this. Right? Shade both sides, but not the 1. So how do we write that as an interval? With commas, because there's 2 pieces. It's not one piece. You can't just trace it with one line, so you have to write it as 2 separate pieces. What would we say? Less than 1? Or greater than 1? Is there another way we might be able to write that? What do you think? Right. So here would be one way. Let's say, or we could say that x is not equal to 1, but it is an element of real numbers. That would be the other way. Does that make sense? That those are both the same? Okay, so you could write one of those two. It's the same thing. Now, what if we did the same question, but we switched the sign to be less than or equal to? What would have happened when we tested? So we'd get the 1. What would happen when we test if we wanted negatives instead of positives? Instead of saying it's true, we would have to say, when we test our number, we'd say, is 1 less than 0? No. And when we tested the second number, so our first number was 0 and our second number was 2, when we test those same two numbers in the original, we still get 0, or 0 plus 0 plus 1. So we still get the same thing with the sign opposite, and they're both no. So what would the solution be? So this side does not work, and this side does not work. No, not no solution. Right, because I put an equal sign here. Yeah, do you see it? So the 1 itself works, but nothing else. So the 1 works because of the equal sign. All right, the equal sign in the... So x equals 1 is the only solution to this one. And it would be no solution if I didn't put the equal sign. So if we said... this one, we don't want the 1 and we don't want either side, so here we would say this has no solution. Okay, so here's the next one. Step 1. Change it to an equal sign. So you rewrite the equation. We go back to this later when we check, but we don't actually use it. We don't rearrange it. We don't factor it in this form. So you change the sign to an equal sign. Now how do we solve this? Always. It always has to equal 0 to solve it. So bring the 13 over. Nine. Good news, that works nicely. What is it? Difference of squares. So we get x plus 3 equals 0, which is negative 3, and x minus 3 equals 0, which is positive 3. Put them on a number line. So negative 3 and positive 3. Now the intervals are, when you're in between two numbers, you would say that it's in between 3 and negative 3, greater than 3, and here is x is less than negative 3. Okay, so those are the possible intervals. You could have 1, 2, or 3 of them, or none, I guess. And how do we figure out which ones are the answers? Test one number in each region. So how many numbers do we have to test this time? 3. So we're going to test, pick a number less than negative 3. I'm going to just put it in a circle here. Negative 10 I like better than plugging a 4 in. Because what's 10 squared? 100, 10 times 3 is 30, like it's a little easier to plug in. What about a number in between? 0 is good. And a number bigger? 4, 5, 6, 7, 8, 9, 10, 100. Let's go with 10. Now we're plugging these into the original. So x squared plus 4 is greater than 13. And we just want to see if that works. Yes or no. So minus 10 squared plus 4. Minus 10 squared, positive 100. Is 104 bigger than 13? Yes, so this region works. So that's part of our solution. The next one, 0. So again, plug it into the original. So 0 squared plus 4 greater than 13. Yes or no? No. So this is not the solution. And the last one, positive 10. That will work as well. It's the same thing as here. 100, 10 squared plus 4. 100 plus 4, and that works. Okay, so we see what regions work. We practiced doing this in our last section, writing the answers to these. Once you know on a number line where the solutions are, we practice writing them out. This is in 2 places. Do we want the equal sign or not? Look at the original question. Well, I wrote it a bunch of times. Do we want the equal sign or not? No. So we don't want those numbers. We want these intervals without the equal signs. Can you put those together in 1? No, not when they're separate. Unless you can trace it as 1, you can't put it together as 1. So the solution is that x is less than negative 3 or x is greater than 3. Why is it not and? You can't be both places at the same time. Whenever there's 2 pieces, it's always or. Here or here. Change sign to an equal sign. How do we solve that? Move the 2x over. Always the same step. We want it to equal 0. Don't get any bright ideas to divide by x. Right? We talked about that last class. This is a common factor. We can take out an x. If we divide by x, each of these terms, there we go. Now what? Write the solution to this, so the actual roots. So this one gives us x is 0. 0 times anything is 0, and x minus 2 equals 0 is 2. So we've got 2 roots. Oh, let's change the sign to an equals, because the last one we didn't have it. So just add an equal sign here. Go back and add that. Okay? Let's change that to an equals. All right, what do we do with our 2 numbers? Number line and test them. So put them on a number line. Will this method, these steps, work for the other ones that we did, the inequalities that are linear? Could you change the sign to an equal sign and then test? Yeah, you can do it always. And later on, you can do it with cubes and things like that. So the method works for all powers. The linear ones are the only ones you can just rearrange to do it. So let's just write the intervals for practice. So I just put those in there, bigger than 2, between 0 and 2, and less. Pick a number. Less than 0. Negative 10, negative 1, let's go negative 1. Between 0 and 2, 1. Sometimes you'll have to use a fraction. The numbers are close together. And bigger than 2? 3 if you want, 10, okay? Anything. So we're going to test. Back into the original. We want to test negative 1. Negative 1 squared is 1. All right. Is 1 less than negative 2? No. putting in positive 1 for the middle interval. 1 squared less than or equal to 2 times 1. 1 less than or equal to 2. Is 1 less than 2? Yes? Did you say no? It's okay to get it wrong. It's okay. It's better to guess than just to be too scared to guess. So 9, is 9 less than 6? No. There we go. All right, so we've tested it. We know which part works. The only question is, do we need the equal sign or not? Yeah, and we went back and added it in, so it means we do need the equal sign. We want the interval that's in between, because that was the only one that worked, so I already wrote it down. So the solution then is that x is between 0 and 2, and we want it to be equal, so we put the equal signs on. So between 0 and 2. Okay, so let's look at type 3. So this is a type that has the absolute value and the inequality. And we did these. You have to rewrite the question first into 2 inequalities without the absolute value. So your first step is to rewrite as 2 inequalities without the absolute value. Now what I usually did is I thought about this as a distance, and I said, okay, well the distance in absolute value is how far it is away, so the distance is bigger than 3. So if we look at 0, 1, 2, 3, so we want to go this way, right, bigger than 3, but you can also go 1, 2, 3 in this direction. That would be the number minus 3, and it goes this way. So when it's greater than, it means bigger than 3. And if you look at my solutions, even on the assignment solutions, or if I were doing this somewhere else, I always just draw the little picture. I notice a lot of you don't. You just try to copy what I did next, but you didn't do this. And if you don't have sort of the sense of what it means to be greater than 3, then when the questions get more complicated, it's going to be harder, because you're trying to memorize instead of knowing what this means. So this means we can be here or here. It's 2 different intervals, so you have to put an or in between, because they don't overlap. So here we would just say this is x is less than negative 3, or x is greater than 3. Nothing to solve. Okay, but I wanted to remind you what that looks like. And what if it was a less than sign? How does that translate? So less than 3 away from 0 is anywhere in here. These are all numbers that are closer to 3, and these are numbers that are a distance closer to 3. So this is all one interval, so we would say that it's between negative 3 and 3. Now how do we actually solve this equation when we go to solve it? This is solved, there's nothing to do. But we have to break it down into 2 with an and in between. Okay, so we're going to do both of these examples, but put in quadratics in. Okay. So the way I solve these, and the way I did it with the linears, I say, okay, that's a 6, so let's put negative 6 and 6. When it's an absolute value, you always have to look at both cases. We want which sides? Between the 2 or on the outsides? Greater than 6, so we want on the outside, so we're going this way, and this way. So instead of just an x now, like these, we've got x squared minus 3 is less than or equal to negative 6. That's this one. Not worrying about this number anymore because we've taken care of that by looking at this number line. So we want this one. And do we put an and or an or? Or, because they don't overlap, they're two different pieces, so here or here, this one would be greater than 6. So x squared minus 3 is greater than or equal to 6. And I put the equal signs on both because there was an equal. Okay? And so this now, once you do that first step and you get them written down what you want, we're back to type 2 because we're just solving inequalities. We don't have an absolute value anymore. We've gotten rid of that. So now we just have type 2 where we've got two different inequalities. And what's the difference here? Is we're going to get a set of answers for both and we have to put them all together on one number line. So it's a little bit harder. Some of them might be eliminated. Okay, so let's solve the 2. So here, let's call this A and this one B. We'll need all the room for both of them. Okay, so to solve A, x squared minus 3 is less than or equal to negative 6. Change the sign to an equal sign. Move the 6 over. And solve. What do we do for this one? Nothing. It's a sum of squares that can't be factored. There's no answer to this. We can't put a number in and add 3 to it to make 0, so there's no solution. I guess we don't need all the room. We can do B right beside it. So that one didn't give us any numbers to put on the number line. Second one, x squared minus 3 greater than or equal to 6. Whoops. X squared minus 3 minus 6. Difference of squares. So we've got two numbers. So here we didn't have any numbers to put on the number line, and here we've got 2, so we just put 2 on. And what do we test? What do we test? Original. So you don't need to do each of these separate and test them separately. What you're trying to solve is this. What we ended up with are numbers here that make this equal to 6. The distance equal to 6. Now we want to figure out which ones make the distance bigger than 6, which intervals. So we've got two numbers to put on our number line. Negative 3 and 3. We're going to test in each region, so maybe negative 10, between negative 3 and 3, let's go 0, bigger than 3, 10. You're plugging them back in, not to this. That's where we got them, but we're using all of these numbers. We don't want to solve this question. We actually want to solve the original. So you're going back to the original. So our original is x squared minus 3 is greater than or equal to 6. So we're going to plug in negative 10. Oh, this is good practice for you. Let me just solve this. Negative 10 squared is 100, minus 3 is what? What's the absolute value of 97? 97. Is that greater than or equal to 6? Yes. That was our negative 10. Plug in the 0. 0 squared minus 3. 0 minus 3. Negative 3. What's the absolute value of negative 3? Positive 3. Absolute value is the distance. distance is always positive, is 3 greater than or equal to 6? No. And x is 10. 10 squared minus 3. 100 minus 3. 97 again. Greater than 6? Yep. All right. So what's our solution? We've got two parts. Do we want the equal sign or not? Does the original question have an equal sign? Yes. So we want the equal sign, so we want to include those numbers. And then the parts that worked were here and here. So we would say x is less than or equal to negative 3, or, because they don't overlap, x is greater than or equal to 3. Okay, so what we'll do next class is we'll start with an inequality, or an absolute that is less than, because that one's a bit more complicated, and then we'll do a few examples of these. Okay, your assignment is due